Imagine the Earth's atmosphere, also known as the ionosphere, as a thick soap bubble. It is a membrane, a natural electrically charged shield around the Earth, protecting all life from deadly solar radiation.
We have to have the atmosphere for survival. I don't think we should do anything to damage it.
Without the ionosphere, I'd be fried, you'd be fried, all life on Earth would be fried.
In 1912, Nikola TESLA, a visionary genius, saw ways to tame the sky, to make the atmosphere glow. He developed alternating current, high-frequency radio technology, and free energy. He experimented with both high and low frequencies and electromagnetic waves. He envisioned altering the weather and creating shields around the Earth to protect us from missiles, and he claimed he knew how to split the Earth in two. In 1985, Bernard Eastlund applied for patents that could make some of these ideas real. Many claim that these patents have become the blueprint for HAARP, High-Frequency Active Auroral Research Program.
ARCO originally approached me in 1984 to find a use for the natural gas on the North Slope of Alaska, which they could not sell. To give you a feel for how much gas they asked me to find an application for, it was enough gas to produce all the electricity in the United States for a full year. I originated some ideas for military applications and beneficial civilian applications in which that gas would be converted into electricity and then used to power some gigantic antennas.
What does HAARP do? HAARP is a large antenna where we beam radio frequency energy up into the upper atmosphere, and we create on a small scale what the sun normally does. And the reason we're trying to do this is because when you have disturbances in the ionosphere, we can't communicate with our satellites.
HAARP began with a congressional insertion in the appropriations bill of fiscal year 1990. In essence, Congress directed the Defense Department to explore the potential for using the auroral regions for improving communications and navigation and surveillance. From there, the assignment came that the Navy and the Air Force were to manage the program. It is people from those two organizations that have worked together for the past 7 years.
Applications discussed in the patents included destroying missiles. Communications control and disruption were included. There were some other ideas both to possibly modify weather and finally to lift a portion of the upper atmosphere further out into space where hopefully it would be able to deflect missile trajectories.
What we do by beaming up radio frequency up into the ionosphere, that radio frequency, when it hits molecules of atmosphere, it tends to make the subatomic particles inside move faster, and that increases their temperature. So you can bring their temperature up to like 1600 degrees or so, which is normally what the sun does to those particles at that atmosphere.
The ionosphere of the Earth has got enormous amount of energy. There are 8,000 thunderstorms going on all over the Earth at any given moment. There are millions of amperes of electricity pouring to the Earth from lightning strikes, and HAARP could create a trigger effect.
In 1983, I did radio tomography with 30 watts, looking for oil in the ground. I found 26 oil wells over a 9-state area, and 100% of the time was accurate with just 30 watts of power beaming straight into solid rock. HAARP uses 1 billion watts beamed straight into the ionosphere for experiments. Picture these strings on the piano as layers of the Earth. Each one has its own frequency. What we used to do is beam radio waves into the ground, and it would vibrate any strings that were present in the ground. We might get a sound back like, and we'd say, that's natural gas. We might get a sound back like, and we'd say, that's crude oil. We were able to identify each frequency We accomplished this with just 30 watts of radio power. If you do this with 2 billion watts, the vibrations are so violent that the entire piano would shake. In fact, the whole house would shake. In fact, the vibrations could be so severe underground that could even cause an earthquake.
While we feel that HAARP is a unique facility, it's not the only one like it in the world. HAARP has some capabilities that we feel are better than some of the others. You can change the frequencies. You can shift the beam so that you can move it from one part of the ionosphere to another, and it has quite a bit more power than some of the other facilities throughout the world that are doing the same kinds of research.
I chose what's called a phased array antenna for the patents because it can be aimed. Picture holding your microwave oven in your hands with the door open. Then you can move it around and send those microwaves different directions. And for these applications where I wanted precise control of where the power was, I felt that was the best type of antenna to use. And that is the kind that HAARP has built.
What we can do with an antenna is change the portion of the sky into which we insert the energy.
HAARP can create some of the effects that the sun creates that are similar to the aurora borealis.
HAARP can paint designs in the sky, if you will. You know, it can take the beam and move it in any pattern that the scientist who's doing an experiment might want to do.
What I'm holding in my hands is an electrodeless lamp. In it, I have a low atmosphere gas, somewhat similar to the atmosphere above the Earth. I'm now going to put this in the microwave oven, which will irradiate it with about 1 watt per square centimeter.
You know, you put 1 watt out and you've got the fields necessary to break down the air, or whatever happens.
And you see all of the motion of the plasma. That's typical of what will happen at high altitude when the ionosphere gets irradiated with these big beams.
That was 1 watt per centimeter. HAARP focuses 3.6 million watts and squeezes it into a billion-watt or gigawatt beam.
We're squeezing the megawatts into a narrow beam. Then in a very tiny area, you can create what's it called, an effective gigawatt.
Is HAARP safe? Yes, HAARP is safe.
The Earth is a web of interconnections. How do we know what we're doing when we blast the upper atmosphere with a huge amount of energy?
It takes a tiny, tiny amount of energy to release a huge amount of energy. It's the same as a bullet, for example. If you have the primer on the back of a bullet, and that primer releases a tiny amount of energy, but it triggers the larger power in the bullet itself. And HAARP is playing with the energy system of the Earth.
In the HAARP program, we have, I believe right now, 18 different colleges and universities that are working the program with us. University scientists are interested because they're studying science, and this is a major effect on the Earth, and so they want to know more about what it is and what it does.
HAARP has no effect on the Earth.
HAARP began in the 1980s when we were just beginning to learn about chaos theory, how a tiny stimulus can change the dynamics of a living system like the human body or the whole living Earth. I don't think the people who developed HAARP were even aware of that science or its impact in the life sciences. Today, our knowledge is much bigger about how tiny effects can drastically shift the health or well-being of a living thing.
It is possible with a big beam to take a part of that upper atmosphere and push it out further.
What they're not paying any attention to is what's happening to the ionosphere while it's being held 80 miles out into space by this high-energy beam. It's heating up. And all of the molecules in that ionosphere region are absorbing energy out of that radio beam. And if they pick the right frequency to push that plume out into space, that energy may discharge back out of the ionosphere, back down the radio beam, and strike the Earth. And it would be about 100 times the energy released out of a thunderbolt. And that's how much energy would be released.
In certain applications, the military acknowledges that it can literally lift the ionosphere. And what they say is, it's not a problem, it's a short period of time, yet when you lift the ionosphere up, the lower atmosphere rushes in and fills that void, which changes localized weather patterns.